Module 2 deals with graphing linear equations. So let's start with some vocabulary. First of all, the x-intercept. It's the place where the graph touches or passes through the x-axis. To find the x-intercept, you will set y equal to 0 and solve for x. The ordered pair will look like this. It'll have the x value, whatever you found by solving, with the y value being 0. The second coordinate for the x-intercept will always be 0. The y-intercept is the place where the graph touches or passes through the y-axis. To find the y-intercept, you will set x equal to 0 and solve for y. The ordered pair will have a 0 first because you had to set x equal to 0, followed by the y value. The slope is the change in the rise over the change in the run. It's the ratio of change as you move from one point to another on a graph. And we'll talk about this more in a second. Slope-intercept form is y equals mx plus b. The m is the slope, and the b is your y-intercept. To graph using this form, you will start by placing a point on your y-intercept. Remember that your y-intercept is placed on the y-axis. That's where a lot of students make their mistake. We'll go through a lot of these problems coming up. Okay, let's start by graphing an equation y equals 2x minus 1. So we're going to graph this using slope-intercept form. So we're going to start by writing our slope. And remember, our slope is the value in front of your x variable. So in this case, our slope is 2. But for purposes of graphing, I'm going to write it as 2 over 1. And my y-intercept is shown here, and it's negative 1. So the coordinates of my y-intercept are 0, negative 1. So to graph, I start at my y-intercept. So remember, on my y-axis, that's my vertical axis, I place a point on negative 1. My slope is 2 over 1. It's a positive 2 over a positive 1. So from that starting point to negative 1, the change in the rise, which is my numerator, is 2. So I move up 2 units from negative 1. And then my denominator is positive 1. So my run, or the change in the x, is 1. So I move to the right 1 unit. So from my starting point at negative 1, I move up 2 units and to the right 1. And I simply connect these points with a line. My next equation is to graph y equals negative 4x plus 2. So again, I'm going to write my slope. And my slope is negative 4, but for purposes of graphing, I put negative 4 over 1. Notice the negative is only in the numerator. My y-intercept has coordinates 0, 2. And remember, that's my starting point on the y-axis. So the first thing I do is I come to my y-axis and I put a point at positive 2. My slope is negative 4 over 1. So the change in the rise is negative 4. A negative change means I'm going down 4 units. So from positive 2 on my y-axis, I go down 4 units. And then my denominator is positive 1, so I move to the right 1 unit. Next, I just connect these with a line. Next is graph the equation y equals 1/5 x. So again, I'm going to identify my slope. So my slope is identified as a fraction already. It's positive 1/5. And notice there's nothing being added or subtracted to that 1/5 x. It's implied then that there's a 0 there. So that means my y-intercept has the coordinates 0, 0. So I have a starting point at the origin, which is 0, 0. My slope is 1/5, so the change in the rise is 1. So from 0, I move up 1. The change in the run is +5, so I move to the right 5. Again, you're going to connect these 2 points with a straight line. Another example, we're going to graph the equation -2/3 x plus 1. So again, we identify our slope. And remember, the negative goes with either the numerator or the denominator, but not both. So I'm going to put it with my numerator. So my slope is -2/3, and my y-intercept has the coordinates 0, +1, and that's my starting point. So remember, you're starting on the y-axis. So I start at +1 on my y-axis. My slope is -2/3. So the change in the rise is -2. So from this point, I go down 2 units, and then to the right 3. Again, connect your points with a straight line. Notice that when I have a negative slope, my line looks like it's going downhill as I move from left to right. My next example, I have 2x plus 3y equals 6. Notice it's not in slope-intercept form. So slope-intercept form is y equals mx plus b. So here I have different alternatives to graph, but I want to keep with graphing my lines using slope-intercept form for now. So what I need to do is change this equation to the form y equals mx plus b. So I'm going to start by moving the x on the other side of the equal sign by taking its opposite. So this would give me 3y equals -2x plus 6. Notice I put the x first because in slope-intercept form, the x comes before my y-intercept. Remember also that I'm solving for y, not 3y, so I'm going to divide each term by 3. So this would give me y equals -2/3 x plus 2. So I'm going to identify my slope, -2 over +3, and my y-intercept is 0, 2. And that's my starting point on my y-axis. So I go up 2 units to place my first point. My slope is -2/3, so from 2, the change in the rise is negative, so I go down 2, and then to the right 3. And again, connect your points with a straight line. So I recommend that you get used to doing this because it makes it much easier to graph if you can put the equation in slope-intercept form. Okay, so now here's another method of graphing, and that's to find the x and y-intercept and plot those 2 points on our graph. So remember, when we're finding the x-intercept, which we'll do first, we set y equal to 0. So to find the x-intercept, I set y equal to 0. So now I have 2x plus 15 times 0 equals -6. So all I've done is substituted 0 in for y. So 15 times 0 is 0. So that just leaves me 2x equals -6. And now I'm going to divide both sides by 2. So x equals -3. So my y-intercept has the coordinates -3, 0. Remember, I always substitute y in 0 in for y. And so notice my second coordinate is 0. Now I need to find my y-intercept. So to find my y-intercept, remember you substitute 0 in for x. So I have 2 times 0 plus 15y equals -6. And 2 times 0 is 0. So that's just going to leave me 15y equals -6. And remember, you're solving for y. So you're going to divide both sides by 15. Now keep in mind I can reduce. So 3 goes into both -6 and 15. So I'm going to divide 3. That gives me -2/5. So my y-intercept has the coordinate 0 and -2/5. Now I'm going to graph these 2 points. So I'm going to graph -3, 0, and 0 and -2/5. Okay, so -3, 0 is pretty easy since that's an integer, and that point will fall on the graph. Remember, that's your x-intercept, so it's got to fall on your x-axis. Our y-intercept is -2/5. We're moving in increments of 1, so you're going to just have to estimate where that's going to be. So from 0, since it's negative, I'm going to move down. It's going to be below the x-axis at -2/5, which is about there. So again, what you're going to do is connect these 2 points with a line. Next example, again, we're going to find the x and y intercept and then graph. So the first thing I'm going to do is find my x-intercept. So to find the x-intercept, I'm going to substitute 0 in for y. So this gives me 5/2 x minus 4 times 0 equals 1. We know 4 times 0 is 0. So this leaves us 5/2 x equals 1. So there's different methods you can use to finish solving. Anytime you have a fraction that's a coefficient, your coefficient is the value in front of your variable. If it's a fraction, all I need to do is multiply both sides by its reciprocal. Anytime you multiply a number times its reciprocal, the product or the answer is 1. So when I multiply 2/5 times 5/2, that just gives me 1x. So I have to multiply the right-hand side by the 2/5 as well. And 1 times 2/5 is simply 2/5. So my x-intercept would have coordinates 2/5 and 0. To find my y-intercept, remember, we're going to substitute 0 in for x. So I have 5/2 times 0 minus 4y equals 1. So 5/2 times 0 is 0. So that's going to leave us just with a -4y equals 1. And we're solving for y, so we're going to divide both sides by -4. So our y-intercept has the coordinate 0 and -1/4. So again, we're going to graph these on the coordinate plane. So I have the x-intercept being 2/5, 0, and the y-intercept having coordinates 0 and -1/4. Again, since we're moving in increments of 1, we're just going to have to estimate. 2/5 isn't 1, it's less than 1. So our x value or our x-intercept is going to be at 2/5, 0. And our y-intercept is at -1/4. So again, not to 1, it's closer to 0. So we put in the point there, and we're going to connect these 2 points with a straight line. Now, in some cases, we're going to be asked to graph an equation that has only one variable. Notice in this case, it's x equals -3. Anytime we're drawing a graph, we're illustrating all the possible solutions or all the solutions for a given equation. So this is asking us to indicate everywhere where x equals -3. So we know that x equals -3 as far as the x-intercept is concerned, is here. But remember, it's not saying the value of y. Y can be anything. So if x equals -3, we know that x equals -3 at any point 3 units to the left of our y-axis. So this would have a value here of -3, -2. Our first point that we put had coordinates of -3 and 0. So notice that our x value is -3. That's what they're interested in for this problem. So if we connect these 2 points, we're going to have a vertical line. So always when we have one variable and the variable is x, we'll have a vertical line passing through that particular intercept. The next example, we have 2y plus 6 equals 0. So notice it's not solved for x or y, but notice we have only one variable. So anytime you have a single variable, you're going to solve for that variable. So here we have 2y plus 6 equals 0. So we're going to subtract 6 from both sides because we're solving for y. So 2y equals -6. And then we're going to divide both sides by 2. So y equals -3. So again, it's asking us, where is y -3 on the graph? Well, we know it's -3, 3 units down from the origin, but we also know it's 3 units down from our x-axis. So if I look at the 2 points that I graphed and look at the coordinates, the first one has coordinates of 0, -3, and the second one has coordinates of 2, -3. Again, notice our y value is -3. So we graph this, we're going to have a horizontal line passing through those points.